We are going to finish chapter 10 today, classes, and we stopped here last time at the initial user interface of point of sale 1. And just to recap a little bit, the design decisions we went through, we want to be able to create a pizza class that calculates its own price, that creates a text description of itself, and has any getters and setters that it would need to be able to work with it effectively. In terms of the attributes, there's 4 attributes: size, crust style, toppings, and price. And we talked about whether those should be stored as string values or integer codes. And we ended up with integer codes so that, for instance, the crust style won't be the text, small, medium, large, etc. It'll be an integer number, 0, 1, 2, or 3, or so on. And then we'll write methods for both size and crust style to convert those integers into string descriptions, and we'll talk about those in a little bit. There's certainly pros and cons to both approaches, and I'll try to point them out as we see them. The toppings are currently just an array of strings. In this first example, just the text topping 0, topping 1, or topping 2 to keep things simple. But we will be, future point of sales, we'll be having distinct topping types, and also each topping will come with its own price to make it a little bit more realistic. Price is mainly a little method that multiplies the size of the crust and the number of toppings by some integers to get a realistic price. We will be talking about static variables a little bit later, and so this does also have an example of a static variable called overhead. It's an attribute of the pizzeria, and it represents the overhead rate for all food in this restaurant. So it's an additional fixed value that all pizzas will get, and for instance, when we move on, beverages would get, or other food items would get, etc. It's a shared variable, a static variable, related to the pizzeria itself, the point of sale itself, and not individual pizza objects. The main simplification we've made to get this off the ground is when you hit the new pizza button, you will get a new random pizza. So a random integer will be generated to represent the size and the crust style. And that's another advantage of this approach, is since those attributes are already integers, picking a random size is as easy as just generating a random integer in the right range. So the constructor will create a new random pizza when you add a pizza. That's the simplification. There's no interface here to allow you to input crust style or size, or to make edits or changes to a crust style or a size, because that would add significantly to the complexity of the app, and it's not something we really need to look at right now. What we're looking at right now is how do we create and use, say, pizza objects? How do we create our own class to encapsulate the data and the methods that we need, and then use it in an app to take advantage of the work we put into designing the class. We will, in future examples, add on to the interface to allow individual pizzas or food items to be sized and styled directly instead of obviously random. Random is a simplification. It is obviously not what you would want in a real point of sale, or in your team's project point of sale. You want the user to be able to specify exactly what is being purchased. And then the UML was the last thing we talked about. It's going to look like, the pizza class is going to look like this. It has 4 default or package level attributes: the size, the crust, the toppings, and the price. It has the constructor, which generates the random pizza. And then it has 4 methods: getPrice, which calculates the price; getSizeAsString and getCrustStyleAsString, which convert the integer size and crust style codes into descriptive text. And then the string method toString, which returns the text description of each particular pizza object. And here's where we stopped. So it is a super easy UI. It's a JText area and a JScroll pane. And those are just text written out or appended out to the JText area every time you hit the Add Pizza button. When you hit the Place Order button, the dialog pops up like you see on the right and says payment of whatever the running total is. Your pizzas are on the way. So I'm going to switch over to Eclipse and run it so that you can see see it in action, and then we'll move a little bit ahead. All right, so Pizzeria Point of Sale 1 is just this really simple UI. If I hit add pizza, I get new pizzas added to the list. They're not really formatted as money. That's not something I've added to this version. This is just text in a JText area. And then if you hit place order, you get this also badly formatted running total, $116.30, and just a little tiny bit more. Certainly the pizza is not of a quality that would be deserving of that price. I think we can agree. All right, let me switch back to the key. The button handling I'm actually going to get to in a little bit, but there's nothing really complex about this in the point of sale. I use actionPerformed, and I use getSource to figure out if it was the add pizza button. If so, I create a new pizza, I increment the pizza price, and I add the pizza, append the pizza to the list. If it's the take order button, then I just pop up that J option pane with the running total, and a message saying the pizzas are on the way. So when we create pizza objects, this is the key syntax. Instantiation, we'll say something like pizza equals new pizza, or pizza equals new pizza, but that's a lot of pizza. In the example, the way I'll type it in is capital P pizza P equals new capital P pizza to create a new pizza object. But once we have a pizza object, in this case lowercase p pizza, we can access its price using the object.attribute syntax. We can get it to regenerate its own price using the pizza.getPrice method. And we can get the text description of a pizza using pizza.toString. Yeah, note the total price and overhead are not part of pizza objects. They're attributes of the point of sale, which is where they make sense. It would make sense for individual pieces to store the total price of the order. That is a variable or attribute related to orders, not to pizzas, so that's why these are located where they are. Okay, so let's switch back to Eclipse, and let's look at the pizza class in more detail. Here is the pizza class as promised in the UML and in the discussion. So it's called pizza, capital P pizza. It has the 4 attributes as promised of the correct name and data type. Here's the constructor. Pizza constructor creates a random object and then uses that to generate a random integer for the size and a random integer for the crust. Then a little bit of an expression here. I want a random number of toppings, but I don't want to allow 0 toppings because that's our moneymaker. So the expression is written so that it's 1 plus a random integer, which gets me a random value between 1 and 3. And then however many random toppings I generate, which I called ntop here, I do a for loop that adds that many toppings to this array of strings. So again, in the future, this will be something more descriptive like pepperoni or cheese or mushrooms. Right now, all it says is topping and then a number. So it'll say topping 0, 1, or 2. And then I call the getPrice method, which recalculates the price. I've got that down here. This is a slight modification from what's in the keynote in that it also does the 2 decimal place rounding, although it also needs to be done in the point of sale for the running total, but I don't. These are all niceties I add to point of sale 2, which we'll get to later. But yeah, so there's a bit of an oddity here, I guess. You might be thinking, well, hey, why do we want to get price method? Why not just calculate the price up here in the constructor? And you certainly could. We're not going to want that longer term because we'll want to be able to recalculate prices. For instance, if a coupon is entered on a particular pizza or a group of pizzas, then we'll want to be able to go through and recalculate the price on all the pizzas. And if the price calculation was in the constructor, that would be difficult to do. But if it's its own method, then it's easy to call getPrice anytime we want to get the price. And as a get method, I have it returning the current price, although that is a weird way to code it considering the price is an attribute. So it's an in-scope attribute variable. So according to the guidelines we talked about last time, you do not need to return the price because it's already an in-scope variable. That said, for get methods, the expectation is that they do return a value, so I coded it in a way that was consistent with that expectation. So I could change it and make it a method more like updatePrice, and that would make maybe more sense, and then I wouldn't need to return anything at all. Okay, let's look at the toString here. So I'm on line, it's 84 of the pizza class. So it's a string method, it returns a string, it's called toString, which is the default expectation. and it just builds up this text to return. So it gets the size and gets the crust style as string. So it calls getSizeAsString, and then it calls getCrustStyleAsString. So let's jump up to getSizeAsString and see how that works. So remember, size is just an integer attribute. It can take on the values 0, 1, 2, or 3, but we don't want to use these when telling the customer what they've ordered. It doesn't make any sense to say, thank you for ordering a 1 pizza. You want to say a medium pizza. So this uses a switch block based on the current value of the attribute size to return a descriptive string. So small for 0, medium for 1, large for 2, extra large for 3. And if for some reason the value doesn't match one of those, then a descriptive error message which would point that out to the user, quickly. This is a perfectly good way to do it. You could do this with an if, else if string of statements. It would be a little bit longer. This is one example where the switch block does make the code fairly compact and easy to read. That said, you might like my second approach even better. So getCrustStyleAsString does the same exact task. It takes the integer crust style code and converts it into one of 4 options: regular, thin, thick, and deep dish. To do this, I've created an array of strings called crusts with the strings regular, thin, thick, and deep dish as its 4 values. And then I use a really simple if statement to check to see whether the crust style is valid. So is it between 0 and 3? If it is, there's one line of code then which does the conversion. It returns the value in crusts, which is this array associated with the index, the integer index crust, which is the attribute. So if crust is 0, it returns regular, 1 is thin, 2 is thick, 3 is deep dish. And I check that it's a valid crust value before trying to return an element of the array, because if for some reason crust is not valid, if it's say taken on the value 7, then when I try to look up the value 7 in this array, I'll get an array index out of bounds exception, which is, is a nasty thing to get. So I make sure that can't happen. So toString calls these 2 get methods to get a description of the size, say large, a crust style, say thin, then the number of toppings, which would be like 2, and then the price. Again, not formatted, it's not rounded, it's not formatted. This is Pizzeria 1, about as simple as it gets. So that is this pizza class. The thing is, if we look in Pizzeria 1, point of sale 1, you'll notice it's really small. It's only 65 lines. And it is this short because we've put so much of the complexity into the pizza class. And I want to demonstrate that by just, instead of showing you point of sale 1 running and talking through the code, let's just code a simple pizzeria, use the pizza class, and add some pizzas to an order just to see how all this syntax works together. So if you're into the following along, I'm going to create a new Java class. I'm going to do it in the same package so that I have access to the pizza.java source code file, which is where the pizza class is defined. So I'm going to say new Java class. I'll call it, how do we call it? Oh, point of sale 0. And it is an app, so I need the main method generated. And I'm just going to start coding it. So I'm going to make the GUI, so I'll say extends JFrame. I will be organizing imports pretty much constantly as we start this, but I'll create my app, size it, don't know, set default close operation, and then show or set visible. And there's my constructor. Okay, so let's set up the UI real quick. I need a JText area. If I wanted to scroll, I would need a JScroll pane, but we can leave that off for this simple example. But I need a button, so I'll say JButton add pizza. So that'll be the button that triggers the creation of a new pizza object and its addition to the text area. That's the interface. So I just need to add the text area to the center region of the JFrame. And then I need to add the button, let's say to the south. And then I need to handle the button presses. If you're following along, you can use the lambda notation. I realized earlier in practicing this that I can't because this project is set up to use an older version of Java than supports lambda notation. So I'm going to use this notation, which requires that I reorganize imports and then have it write the actionPerformed method. There we go. So this is where we put the code that executes when the user presses button B. So we want to create a pizza. So the syntax is something like pizza p equals new pizza. So it looks like maybe a weird line of code because pizza is not built in and it's not even defined anywhere in this app. It's not found in any of these imported folders. So how does this work? Well, Java also looks in the package that we're in. Pizzeria 0 is there, and inside the package is pizza. So it can access pizza and create new pizza objects. So we have the pizza object P now. If we want to see what it is, we could say system.println P equals P. And I don't have to say toString here because Java is smart enough in string concatenation here to grab the string representation of P by calling its toString. So this will, every time we press the button, this should create a new pizza and put it out at the console here. So here's, for instance, what it looks like. All right, but that was just a test. So if you're following along, hopefully you've gotten to the point where when you press the button, you can create a new pizza, and then you can peek at the pizza using a system.println just to double check that everything's working correctly. But what we really want to do now is add that pizza to the text area. So you do that by appending. We're going to append P, but here's where the JText area is not smart enough. It sees P and realizes that that's a pizza, and if we hover over the area, it'll say the method appends string in the type JText area is not applicable for the arguments pizza. So it's saying, yeah, you're trying to put a pizza in a text, a text box kind of. How would that work? But if it looked, it would see P has a toString method and it could call the toString method on it. So there's a couple ways to fix this, but maybe the most direct is just to say p.toString. That way we're doing the work that maybe the text area could do on its own but doesn't. And then also remember that the text area doesn't have an append line method, just the append method. So if we want the next pizza to go on the next line, we're going to have to add on a new line character, a \n, which I've done wrong. We need to say plus, quote, \n, quote, which will give us that new line character to start each pizza out on a new line. That should now get us, I'm going to comment that out, but this should get us essentially the same app, except now these descriptions are going right into our point of sale. That is a super, super quick version of this point of sale, and notice just how small it is. It can all fit on screen if you don't count the import statements. We've just written a point of sale in really just a handful of lines of code because we've put so much of that complexity into the pizza class. The pizza is responsible for being a pizza. It's responsible for knowing what its attributes are, granting or restricting access to those attributes, calculating anything pertaining to the object itself, like the pizza's price. All of that is the responsibility of the pizza class, and so all of that complexity has in some ways been offloaded to the pizza class. But now we have this pizza class that we can use in as many point of sales as we want to design if we've written it so that it has encapsulated everything it needs. If it has all of the attributes that it needs, if it has all the methods that it needs, then we can use it to code all sorts of variations, say, of these points of sales, which we will do. I wanted to add one more thing here at least, which was a running total. If we wanted to keep track of the total price of the pizzas, first off, we need to know that that's a double number. So if I want like a running total, I'm going to call it order total. I'll start it out at 0 when the app loads. And then when I create the new pizza, I want to add the price of that pizza onto the order total. So I'll say order total equals order total plus p dot price. And then we don't have a submit order button, but I could just peek at the running total every time a pizza is added. So I'll say order total equals order total plus order total. So this won't look any different except at the console, and it will keep track of the total price. Again, this is not rounded and not formatted as money. We'll fix that in point of sale 2. So it looks like it's working. It's working fine. Obviously, if we had the place order button, then we would erase the text area and clear out the order total as part of that button event handler. Display the dialog, do everything else that needs to be done for that button. But this gives you a complete little example of a point of sale that hopefully you just typed in and got working. We may come back and add another feature to it later, but that's what I wanted to do for now. All right. So public and private, I've already discussed this a lot. We've talked about public and private quite a bit already, but it makes sense maybe to refresh you a little bit now, since now's the time when it really starts to matter. In that, if we put attributes inside of the pizza class and we make them private, then the point of sales will not have access to those attributes or those methods or those objects. So we need to be really careful about thinking through, do we want to make something private or not? And if we make it private, then we need to think through, well, do we want to give access using get and set methods to that attribute, or do we really want it well and truly hidden inside of, say, the pizza class? Or, of course, we could also move the pizza class inside of one of the point of sale classes to make it an inner class, at which point public and private don't matter again anymore. They only matter when talking about two separate classes, ability to access data in objects created from the other class. Or in this case, our ability to access features in pizza when we're trying to work with pizzas in one of the point of sales. So in general, here's a visual, and in the visual, although I use very generic terminology, I use class and outside code. If you're looking at this, you could think of class as the pizza, so it's red like tomato sauce. And then the purple is the point of sale, so P for purple is point of sale. And so in the point of sale, we want to create pizza objects. That is, we want to create objects from this pizza class, the red class. We will have, when we do that, we will have direct access to all of those public entities, variables, classes, objects, methods. Public means public, and we'll be able to view, read, and write, say, to these public entities. Private entities, we have no outside access to at all. So I haven't even listed what they might be, because from the outside code, from the point of sale code, we can't see what's private, let alone access it. So it's as if it was not there to the outside code. Private entities are entirely for the internal use of this class when it creates new objects of its type. If we want to provide controlled access to private entities, that's where we supply getters and setters. So if there are specific private entities that we do want the point of sale to have access to, but we want to control that in some way, then the getters and setters are the way to do that. But again, one of the other goals here is that the pizza class has everything it needs built into it and provides access to what the using class needs, the purple class needs, so that the purple class doesn't have to implement features that it can't access for some reason in the pizza class or that don't exist in the pizza class. We want to provide everything required in the pizza class and access to everything that's needed. All right, visually, this is actually an image you've already seen. It's or a model that you've already seen. When we talked about public and private, we created this example where we had two classes called A and B. We actually typed it in, so you might remember typing along with it. They were really simple classes. Class A just has one attribute. It's the public integer val. Class B had the same thing, but it was private. And when we tried to access B in chapter 9, we found we could not do that. It was, or chapter 10, the beginning of chapter 10, I'm not sure. But we found when we tried to access b.val is, well, we can't. It's private, we can't see it. So if we want to get access to it, we can supply a get method. Here's the get method, and it returns the current value stored in val. So we can get b, a private b, if we supply a public get method to it. And then the get method could, of course, do some additional testing or authorization or something to make sure that you have the right to, say, access the value of b, or your code was executing in the right, the right phase or something to get that value, whatever the case may be. It could check something else that was going along in the code prior to returning val if that was appropriate. Okay, so again, encapsulation is just the idea that you want your classes to be complete and self-contained. They should have all the attributes that you would reasonably expect that they need to store about themselves, and all operations or methods that you can reasonably expect users of this class, users who create objects of this class type, will need to work with those objects. So for pizza, we want all of the attributes. We don't want to leave off an important attribute or an important method that the point of sale will have to provide. If you create say a pizza class that's incomplete, then we'll have to compensate for that in the point of sale. We'll have to add attributes and methods to the point of sale that don't really belong there. And then that also means when we try to do a different point of sale, we have to do that all over again. Or another program we're doing a different point of sale would have to do that all over again, which then means what if you use inconsistent techniques? These are features I'm saying that should be in P but aren't. It should be in pizza but aren't because you forgot or whatever. That creates the possibility of different implementations to try to fix the incomplete class, which can lead to, obviously, to errors. So we don't want that. We want everything that should be in a class like pizza to describe everything that makes sense to describe about pizza objects and methods that we would need to work with pizza objects in the type of apps that we're building this class for, the point of sale, for example. That's the idea behind encapsulation, and then going through public and private and making sure that you're exposing as little as possible and providing controlled access wherever it makes sense to. All right. There are times when we want to create a variable that remains at the class level and is not instead part of objects from that class type. So this is what you might call a shared or a global variable. Java calls them statics, kind of because it's a weird term, kind of because if you think of static electricity, static variables cling to, they stick to the class itself. They don't get passed on via instantiation. So a static variable will have one and only one value for all, say, pizza objects that are created. So I used it to do, we will use it to do a discount, pizza discount value based on membership level. We also created a static for the point of sale. The point of sale static was overhead rate. So each point of sale has its own overhead rate in that kind of implementation. So, and I've got a couple more examples of static as well that we'll get to. At 99% of your coding, you will not be creating static variables. But for those classes, when you're using, object-orientedness out to as far as you can go, and if you want something that's shared among objects of a class type, then that's a static. Just remember that I need to make that static for that to work in that way. One of the ramifications is that the syntax for working with statics will be a little bit different. We'll use the class name dot attribute instead of object dot attribute. But again, it makes sense because that static variable is not part of objects. It's clung to the class. So we ask the class for that attribute if it's static. All right, so here's the example that we're going to get to, which is, this actually has two statics in here. You can see the double P equals Pizzeria.overhead rate. That's the overhead static associated with point of sale 2. And then discount pizza is a new class we're gonna write to add this discount feature to it. And then pizza club discount is the discount on pizzas that you get based on your loyalty club, your booty club point balance. And then I do some bad rounding and return it. I'm not formatting this as money here. I do that later, so all I'm doing is rounding it to 2 decimal places and returning it, and then I'll round it more like money, and I'll format and display it using number format to make it look like money when I get to that point in the point of sale. Okay, so this is point of sale 2, and this one takes a big step forward and actually takes it on several different fronts. I mean, first off, the UI is a little bit nicer looking. I've included the running total over here and formatted it to look a little bit like a point of sale kind of program. I have the add pizza button. I changed it to plus pizza to give me more room. And then I have subtract selected pizza, which will allow you to remove a selected pizza, which is a big step up. And then here's the JCombo box with what you will enter as your loyalty club level, gold for example, and then that will give you, say, a 50% discount on your pizzas, which you can see the customer in the screenshot is a gold member and gets half off on all of their pizzas, which is pretty spectacular. All right, so I have some screenshots here that walk you through how to use the interface, but we're gonna switch over to Eclipse and actually work with it and do it and look through the code. So this is actually where I want to stop. Let's look at the code, and then we'll double back to the keynote to explain some of the pieces in a little bit more detail. We're looking at Pizzeria Point of Sale 2, and it is all self-contained. So I had the choice. I wanted to add this feature to pizzas of a discount rate, and so I could have changed. I could have added. This is the attribute that I've added. Pizza Club discount. I could have just added that to the pizza class instead of creating this new class discount pizza. And you could make an argument that, sure, that would be the way to do it. And in some ways, it would be a lot simpler to do it that way. But there is also this sort of reluctance to go into working classes that have already been tested and are already being used by other apps, and making changes to it. You know, when coding Point of Sale 2, I might make a change to the pizza class if I was editing it that will break Point of Sale 1. And I wouldn't notice it ever until I went back and retested Point of Sale 1. And even then I might miss it. So there's risk associated with editing classes that are already in production, already in use by other apps. Something to approach really, really, really cautiously. That said, in this case, you certainly could. If you're following along or wanting to type this in, certainly you could just add this new attribute to pizza and use pizza instead. Although I do fix the other issue, which is the bad number formatting. So I've created a number format object, and let me see, that's getPrice hasn't changed, but down here in toString, you'll see I used the formatted version of the price. And that's the only other change, is my toString has changed. So if there is a Pizza Club discount that's non-zero, then that's reported in the string. Otherwise, we get the same old string we got last time. And actually, it's not even formatted using number format. I don't know why. We're in Point of Sale 2. It's much bigger, you'll notice. It goes down to line 277, but that's because it includes this entire variation of the pizza class, starting here, as well as setting up the UI and doing the other stuff it needs to do. There is a little bit of extra setup I did for the combo box. I wanted to give you just another example of using classes. We're in chapter 10. Using classes is the core of object orientation, is chapters 10 and 11. So I was thinking about these discount rates, and I thought it might be handy to have a class that describes these discount levels. And it'll have some payoffs you'll notice in a minute. Although I don't know that it's entirely worth the effort for Point of Sale 1. This may be something which comes in more and more handy later. So the class discount level has two attributes: a description of the level and the associated double discount rate. It has a constructor which allows you to specify both of those when creating the object. And then it has a toString method which returns just the name of the level, like gold, and then the discount rate formatted as a percent, like 50%. Okay, so I use it in the combo box. Let's switch back to the keynote here. The combo box setup, here's that discount level we were just looking at. And then I create an array filled with these discount level objects, one for each of the levels: gold 50%, silver 25%, bronze 10%. For wood, you actually pay 10% more. For dirt, you pay 20% more. And then there's essentially an empty one, which is or a 0 one, which is select discount. And that gives you something that's displayed in the combo box when the app starts, and also lets you go back to 0 if you want to get back to okay, this person doesn't actually have a valid discount level, so we're going back to 0. So I create the class, I fill an array up with 6 discount level objects, indexed from 0 to 5, and then I fill up the combo box. My combo box is called Set Pizza Club Discount CBX for combo box. We use the add item method to add something to the combo box, and I add the level. This will display in the combo box like this. Select discount, like dirt, wood, bronze, silver, gold, formatted just like we want because of this toString method. When the combo box displays the contents of these array elements, it uses toString to get their text representation to make it look however we want it to look. So that's the setup of the discount combo box that I've got up here at the top of the code. Okay. This is the rest of the UI setup. There's nothing really surprising here. The big other change is here. I'm using a JList instead of a JText area. So let's run this and see what that looks like. So this is Pizzeria Point of Sale 2. We've got the Add Pizza button. This is still adding, sorry, I hit that twice. It's still adding random pizzas. Not super useful, but a useful simplification. Now, however, I can select the pizzas. So look how that's different. If you're running this, try selecting stuff, because in the JText area versions, we really couldn't do that. You could select text for like copy paste, but you couldn't select an entire pizza, which is what we're doing here. We're selecting pizza objects that are stored in this JList, which now gives us the ability, say, to remove a selected pizza from the order. It'd be really tough to do that not really tough, but it'd be tough to do that in a JText area implementation of this UI, and it would certainly be less user friendly than just selecting and hitting the remove button. And then the discount rate. So this is a discount rate that's shared among all of pizzas. So if this person is let's just say we're a gold member, so we get that 50% discount now for each of our pizzas. The running total is calculated a little bit differently, and I'll show you that in a second, but it also adds the tax. So if you're adding this up and saying, wait a minute, that doesn't add up right, it's because I'm also adding a tax to the order price. And then if I hit place order, we get the dialog pop up. Ooh, that is not formatted nicely. That's disappointing. All right, that dialog box is not formatted nicely, so the buttons are handled here in actionPerformed. On 165 is where order total is. Okay, I've got the UI elements here, the add pizza button, the place order button, the remove pizza button for some reason down here, the JCombo box set up here, and again, the JCombo box is set up with discount level objects, which we'll add to it in a little bit. This is the JList. So what you just saw was that we can select pizzas in the point of sale for removal, and we can select them because they're no longer listed in a JText area, they're listed in a JList. So JList setup is a little bit more involved. It's kind of actually like combo box setup. We start with something called a list model. There's a default list model we can use. I called it data here. And then when we create the JList, the class is capital J, capital L list. We use the new instantiation syntax, and then we pass it the data model. And then to make it scrollable, I've added it to a scroll pane. There's a little bit more going on here in that the default list model contains discount pizza objects. So I'm essentially telling Java that I will only be putting discount pizzas in this JList. It may seem like an odd thing to do. The issue is that JLists can hold objects of completely different class types. Should you want to. 99% of the time you really don't want to, or at least you're putting things in the JList that are related. So for instance, as the point of sale gets more complex, we'll have other food items, but they'll all be related to this food item class. They'll all be sort of in the same class family. So our JList will hold any type of object that belongs to the food item class. It seems like an odd limitation though, or an odd bit of syntax, because although you are allowed to put in wildly different types of objects in the JList, But then when you pull an object out, Java's not sure which one you pulled out, and you have to figure it out and then recast it or confirm it using recasting to make sure Java understands, say it's a discount pizza. If you don't want to have to do that, if you want to be able to use simpler syntax, we'll just confirm to Java in advance when we're setting up the JList, we're going to fill this with discount pizza objects. So when I pull something out, I can expect that it's a discount pizza object. And when I put something in, if it's not a discount pizza object, then that'll be enforced as, a coding error. So that's a helpful little bit of syntax to use, even though it looks a little bit weird and seems a little bit weird. Okay, the constructor fills up the combo box using the technique we looked at in the keynote. The color label is set up here, and I make it a bigger font. And I make it green text with a black background to get the kind of cool effect. I add action listeners to all 4 buttons, and then those are handled down here in actionPerformed. So let's look at actionPerformed first. First off, look at how simple it is. When the Add Pizza button is pressed, we add a new discount pizza. It's 1 line of code. When the Remove Pizza button is pressed, we check to see if a selection was made. If a selection was made, then we remove it. If a selection was not made, then we won't try to remove an invalid index. If Set Pizza Club discount combo box was what got hit, then we read the discount out of it using this syntax. And then set the attribute, the static Pizza Club discount to that new discount based on your loyalty club membership level. And then the Place Order button just presents here's your order, it's on the way. So this looks really simple, and in fact it's too simple. There's more stuff that we have to do when we add a pizza or take a pizza off, like update the order total. So all of that's handled here. I call a method updateOrderTotal because I need to do the same thing pretty much no matter what happens. The user hits a button of some sort, any action performed event I can think of, how I want to go ahead and update the order, make sure everything's still good with the order. So update order is right here. And what it does, big picture, is just loop through the JList. It loops through every pizza that's stored in the JList. It recalculates its price in case the discount level's changed. It resets order total back to 0 and then starts counting order total back up again, so to create the new running total. On Windows, since what we did was pull data out of the array list and maybe change it based on getPrice, we need to then put it back where it was in the JList. So this is a weird little bit of syntax. It hasn't been necessary on the Macs to do this. The Macs update the JList live and Windows doesn't, but I haven't tested this in Java 15. And one of you could tell me on Windows, if you comment out that line 132 and then you change the discount level, does the JList update correctly or not? And then I add tax. That's another static that's associated with the point of sale. So the tax rate will be shared among all orders. And then I set the label, and that's the only place apparently where I remembered to format using my formatter. All right, so let's run it just one more time so you can see the updating of the discount level in action. So if we have several pizzas, and then we say, hey, but we're dirt, so we have to pay more. No. All right, I remember my discount card. I'm silver. So you should see that updating live of the discount rates, updating the prices that are calculated, and then the live update of the order total. And that's all done here in update order total. All right, let's switch back to the keynote. So this is just confirmation of some of the syntax we've just been using. So setting up the JList is this 3-step process by creating a data model, then the JList, and then putting the JList in the scroll pane, assuming we want to be able to scroll it, which we do. Syntax for adding and removing stuff from the JList is to use the add element method. So that's what we did to add a new pizza, as we said data add element new discount pizza. Again, that's a random pizza, so the syntax couldn't be easier. And then to remove it, we use the remove method, but we do want to also double check that the user has selected a pizza to remove. If they haven't selected a pizza to remove, I will come back as -1, in which case we can't remove nothing, and we're not going to guess and say, okay, maybe they meant to select the third pizza, so I'll just guess. No, you can't do that. If they don't select a pizza, in one of the versions will pop up a dialog that says, please select a pizza to remove if you really want to remove something. This is update order total. Just showing you again, we're looping through what's in the JList, tallying up the prices, updating the order total, adding tax, updating the order total, and moving on. All right, this is a cool feature. It's a little bit more advanced, and it will only maybe resonate if you already know some HTML. If you don't know some HTML, this basic HTML formatting that I'm going to show you is really easy. And you can Google basic HTML format to bold text or whatever, and you'll get a million hits on how to do that. But here's the cool thing. The JList will render basic HTML. Which is really cool. Actually, a lot of the swing methods will work with basic HTML. Not the JText area, which is another strike against it, but the JList absolutely will. So if we wanted, for instance, to change the color of certain pizzas or color code them based on where they are in the order process, or flag one as being the lower cost or the highest cost, or underline parts of the piece of text, anywhere you want to render a bit of text but do something to style it, you can use HTML to style it. And so for instance, to underline in the oven, if we have the string your pizza is in the oven and we want to underline in the oven, the HTML formatting would be to start out with the HTML tag that says, okay, everything now to the right is HTML. Your pizza is, the tag U starts underlining, the tag /U stops underlining. So everything between U and /U will be underlined, like right here. And then when you're done using HTML, you supply the /HTML or close HTML sign that says anything now past this is not HTML styled. And that's pretty much the basic idea of any sort of HTML formatting that you want to do. Limitations are to keep in mind is that these swing widgets are not going to be able to render complex, modern HTML5 HTML with, style sheets and all sorts of crazy stuff. So you've got to go back to maybe HTML3 and just pick the basic ways you use HTML to style things. And it will render that. Sometimes it takes a little bit of work to figure out the exact variation of the syntax. You frequently can get it to work, but it's picky about, how you get it to work. But anyway, if you have an idea of something you want to do styled in HTML, know that many of the swing widgets will honor HTML and render HTML. All right, that's chapter 10. It's a big chapter. I don't know if you're counting, but that's 52 slides. We're on slide 52 right now. And we've covered a lot of ground. Remember looking at that point of sale code, 30 minutes ago, and how short it was. And it was short and simple because all of that complexity had been offloaded into the pizza class. Same idea with if you had a customer management app that you were writing. Same idea is you would offload all the complexity of what a customer is into that customer class. It would make it easier to write a UI around something that used customer objects. Or we did the prior customer report and generated a report based on what their current point club balance was, what their level was, gold, silver, bronze, wood, dirt, whatever the 4 or 5 were. In each case, by putting the complexity for those objects in a class that describes those objects, made the rest of our app so much easier. That's what this entire chapter is about. Interestingly, you might have noticed that visually, there's no difference on screen. I mean, you couldn't look at this one from chapter 10 and say, oh, I can see that's different. He's now using pirate customer objects. He's not using just text. He's using, I can tell. Well, you can't tell. On screen, it looks exactly the same. So then it kind of raises the question, well, then maybe it seems like a lot of work to code something this way. The payoff in this chapter is it makes the rest of your code so much easier. It makes creating the point of sale, the UI, working with all the buttons and the interface stuff is now separated from working with pizzas. It can make the syntax much clearer, more elegant. And maybe that seems like a lot to you, maybe it doesn't, in terms of payoff for the effort. I'll tell you, the big payoff is next time. The big payoff of object orientation is that if we want to make additions or changes to a working class, a class that's in production, we now have another way to make those changes. We can essentially get all the features out of a fully working tested app and use it as a starting point to base new classes on to create variations of that object type. So inheritance in some ways is the big payoff of object orientation. If you're not swayed by the simpler syntax or the more elegant syntax or the simplification, the ability to modularize and separate code out, then inheritance is the big payoff. We will start covering that on Thursday.